All right, welcome back. Hope you had a good spring break and you're all rested up and ready to finish this last little leg of the adventure for the year. On the Friday before spring break, we spent a second day practicing trigonometric ratios, or trig ratios for short. And so we pick up where we left off today with a little review, and then a look at how we actually use them to solve problems, not just to write ratios, just for the sake of writing ratios. So the first thing we want to remember is the actual definitions and equations or formulas, if you will, of the three trig functions. So we learned before spring break that if you know some sort of a mnemonic device, it helps you keep your three trig definitions straight. SOHCAHTOA is a popular one that a lot of students use to remember which trig functions go with which sets of sides and in what order. So SOH tells us that sine, the sine is the first trig ratio, sine, which we abbreviate SIN, of an angle. And we usually use some capital letter for an angle, so I'm going to say angle X, equals O over H stands for opposite over hypotenuse. Opposite side is the side of the right triangle that's opposite or across from angle X, and the hypotenuse is, what's the hypotenuse? It's the opposite the right angle. Opposite and adjacent are always defined with respect to whatever this angle is on the left side of the equation. So you need to note that there's a really important structure here. The angle is always the input for the sine function. So the angle is always on the left side of the equation with the trig name. And then on the right side of the equation, you have your ratio of two sides. Now this isn't actually in your notes page. This is just kind of a review. And we'll dig into the actual notes in just a couple of minutes. All right, CAH tells us C is for cosine of an angle. We'll just call it X. So that's an angle. Angle on the left side of the equation with the trig name is equal to AH, means the adjacent leg over the hypotenuse. This is a ratio of two sides of a triangle. So you get angle on the left side, side lengths on the right side. Do not mix those up. Angle goes on the left, side lengths go on the right together. Last but not least, TOA tells us that T is for tangent. TAN is the abbreviation of an angle, we'll call it X, equals opposite over adjacent. Opposite over adjacent leg. Again, X is an angle. Opposite and adjacent are the ratio of two side lengths. So angle on the left side, side lengths on the right side. Can't stress that enough. Lots of students want to kind of jumble those up. You got to keep those separate. Okay, remember that adjacent is the leg that's attached to the angle that's referenced on the left side of the equation, and the opposite is across from, on the opposite side of the triangle. Okay, now in today's lesson and the next 2 days' lessons, we're actually going to use these three definitions, which are really formulas, to solve for missing parts of right triangles. That's ultimately the reason we want trig, is because trig will let us solve for missing sides. It gets a lot bigger than that. Trigonometry is its whole realm of mathematics. It's got its own little realm of study, but for our purposes in geometry, the primary purpose is to solve for missing measurements on a right triangle. Okay, so now that we've got that reviewed, let's go back to the notes. The section 8-3 notes that you already have copies of. If not, there are copies in the Unit 8 folder that you can go back and look at. You can download them, you can click on them and look at them or print them, whatever. Okay, so we would attack a problem like this one using trig ratios or trig formulas. We want to solve for a missing side of the triangle. X is the length of this side over here on the left. I know the hypotenuse length. I do not know the length of this bottom side. 33 is the degree measure of this angle. It is not a side length. That is an angle measure. We can't use Pythagorean theorem here because for Pythagorean theorem to work, you would have to already know two side lengths. We don't know this side length. We don't know this side length. We don't have enough known sides to use Pythagorean theorem. It's also not a special case. It's not a 30, 60, 90 triangle. It's not a 45, 45, 90 triangle. So if you can't use Pythagorean theorem, and it's not a special case, then it has to be a trig question. That's our only other possibility. So the first thing I want to do is try to figure out which of the three trig definitions, which of the three ratios would work for setting up an equation that relates the 33-degree angle and the sides x and 14. So I'm going to use 33 degrees as my point of reference, my angle of reference. So I want to do everything from here. X I'm going to need. So I know that x is the opposite leg. It's across the triangle from 33 degrees. So that's the opposite. 14 is opposite the right angle. That's the hypotenuse. I need a trig ratio that relates the opposite leg and the hypotenuse. And I might just jot down for quick reference, SOHCAHTOA. And I notice that O and H, opposite and hypotenuse, go with the sine ratio, which means I have to use the sine ratio to solve this triangle problem. There's a definition that I need to jot down first of all. Sine of some angle, I'm going to call that big X, is equal to opposite over hypotenuse. So this angle right here, that's like angle big X. All right. Now let's put some numbers in. What would be fantastic is if you could skip straight to the putting the numbers in step, and if you can do that, that's a great thing. You go for it. So sine is actually a function. It does something, just like addition sign does something, a square root symbol does something, sin does something to an angle. So that's really just a symbol. X is the angle. That's the 30 to 33 degrees that we were given. So I need 33 degrees to be my input for the function sine. Equals, just bringing down the pieces of the equation, of the formula, treat it like a formula. I need a ratio of sides. Opposite goes on the top, that's the little x. Hypotenuse goes on the bottom, that's 14. Skip straight to the numbers if you can. If not, write down the formula first and then put your numbers in. Okay, so the setup is finished. So step 1, set up the equation. Okay, and then step 2, use algebra to solve for x. Okay. Now I propose that, because sometimes they get an extra step more than this one's going to require, I propose that you treat these like proportions. Put this sine 33 degrees, that's that's a number. The calculator is going to turn that into some ugly decimal number. Put that left side over 1 every single time. Anything can be put over an understood 1 and still be equivalent to what you started with. And cross multiply. Okay? That's your best option so that every single problem gets solved the same way. It's less confusing if you'll just do it that way every time. When you cross multiply, then you get sine 33 times 14. Now I like to put the 14 in front of the sine 33 because when I type this in the calculator, it's going to make me put the 33 in parentheses. And if I'm not really careful, I might accidentally put the 14 in parentheses as well, and that would give me a wrong answer. So put your coefficient in front of the sine, cosine, or tangent when you cross multiply. And then we cross multiply the other direction. 1 times x is equal to x. Okay? So the good news is we have x on the side by itself. It has been solved. Solving is finished as far as the algebra goes. Step 3 is to simplify. And this is where you have to have a calculator. That you cannot finish these without a calculator. Okay? So you can do all the steps up till step 3 without a calculator. For step 3, we need to know what x is equal to, and 14 times sine 33 needs to be crunched into a decimal number. You've got 2 options, unless you have some other kind of calculator at home, and then you'll just have to kind of play around with it and see how it works. If you have either the Inspire software downloaded or an Inspire that you checked out from me before we started the NTI days, then we'll start with this version. So on a calculator page, we're going to type it in just the way it looks. 14 times sine 33. 14 times. Now the sine is, let me scoot this up a bit, on the trig key beside the 7. So hit trig, and sine is your first option. Having a hard time finding a happy medium here. So when you get sine highlighted, you click on your enter key, and it'll paste in sine and some parentheses, and you put your angle measure in the parentheses. Okay, you should be in degree mode, and then when you press enter, you're going to get the decimal approximation for that side length. So x is approximately 7.6 whatever units. We don't know if it's inches or centimeters. Units were not given, which means we don't actually know the units. So all we know is 7.6 of some units that we just haven't been told. Now, if you're using the Desmos calculator that I have uploaded a link to on your Schoology page, what would that look like? So let's take a quick look at that one. It's pretty friendly. You're going to type it into the Desmos calculator exactly the same way you did in your Inspire. So 14 times, and then you're going to click on your sine key over here and put a 33 in for your angle, and your answer is going to show up even before you hit enter. When you hit enter, 7.6 is your approximate answer. So fortunately, this scientific calculator, this free online one, has really nice math print on it. So it's going to look just like it does on the Inspire calculator. Okay, so now that we've seen the structure of solving these problems, let's do a couple more examples. So flip on to the next slide, where we want to solve for x again. So the first thing I notice is that I have one known side length that I need to solve for a second side. I can't use Pythagorean theorem because I need to note 2 sides before I can find the third one. It's not a special case because I have a 29-degree angle, not a 30, 60, or 45. So this is a trig question. Alright, so this is my angle. And I want to use that angle as a reference point to figure out what kinds of sides I'm working with. So I'll notice that across the triangle, on the opposite side of the triangle, I have x. That's the opposite. The hypotenuse is the unknown side that's not even labeled. So right angle's here, hypotenuse is over here on the right. The 5.4 connects the angle 29 degrees to the right angle. That means it's the adjacent leg. It's a leg because it connects to the right angle, It's adjacent because it's next door neighbor to angle 29 degrees. It touches it, it connects to it. So that's our adjacent leg. Okay, which trig function am I going to use? So, TOA. I have opposite and adjacent. That's an O and an A. O and A go with tangent. So I need tangent of an angle. I'm going to write this one differently just to kind of help us remember that this is always an angle, equals opposite over adjacent. And then we're going to substitute numbers in. So tangent of the angle, 29 degrees. Now, we don't need any parentheses around them on paper. We know we're going to have to put parentheses around them when we put them in the calculator. So if you want to go ahead and put that angle in parentheses on paper, you can. There's nothing wrong with that. It's just not mandatory that you do. Equals opposite over adjacent. So opposite was the x and adjacent was the 5.4. And then to solve it, we're going to put the tangent 29 degrees over an understood 1 to make it look like a proportion. And we're going to cross multiply. So tangent 29 degrees times 5.4. Stick the 5.4 in the front. So we're going to write it as 5.4 times tangent of 29 degrees equals, and then 1 times x equals x. Alright, we got it set up. We have it solved for x. Now we need to simplify the left side, so we're going to get out either of the two calculators. So if I pull out my Inspire, I need to type in 5.4 times, go to the trig key beside the 7, and arrow over to the tangent. Press enter to paste it in, and then put 29 degrees in your parentheses. And that is about 2.99. If you round to 2 decimal places. If you round to just the nearest tenth, this second 9 would make the 9 in front of it round up to a 0, which would carry over to a 3 in the ones place. So 3.0 to the nearest tenth would be the correct rounding, is approximately equal to x. Works the same way on your Desmos calculator, on your online free calculator that you have a link for. And we are finished. We know how long that side is. Typically, if we're given things to the nearest tenth in the original problem, we round our final answer to the nearest tenth as well. Okay, so the structure of all of these questions is exactly the same. You start by labeling on your calculator what types of sides you have with respect to a given acute angle, and then you set up the appropriate equation to match that pair of sides, and then you solve and simplify. Alright, so we want to look at a couple more additional examples, and this next one I'm going to change just a bit, because otherwise we're not going to look at a cosine problem, and I failed miserably to put a cosine problem in this set of notes. So I'm going to scratch out this x right here. You're going to do the same, and we're going to move it over here to the hypotenuse so that we have a cosine example to work. Okay. But we're gonna start off pretending we don't know it's a cosine example. Okay, we know it's not a Pythagorean theorem question because we have two unknown sides. It's not a special right triangle because we don't have an angle measure of 30, 60, or 45. Our given angle measure, and we know this is an angle because of this degree symbol right here, is 55 degrees. It must go with this bottom left hand corner. That's the only acute angle anywhere near that marking, anywhere near that number, so it has to go with that one. So we're going to use trig to solve it. With respect to 55 degrees, the opposite side is unknown. The hypotenuse is the x. It's opposite the right angle, so that's the hypotenuse. And then the 33 units long side down here on the bottom is adjacent to or attached to the 55 degree angle. So that's the adjacent leg. It links the angle that you're using, the acute angle that you're using for reference, to the right angle. That's always your adjacent leg. So we have hypotenuse, that's an H, and adjacent, that's an A. And if I write my mnemonic device, so ka, toa, I can see that A and H go with cosine. So I'm going to need a cosine equation for this one. So I'm going to need cosine of an angle equals adjacent over hypotenuse. Now some of you may already be able to just go ahead and skip to the numbers. If you can, that's fantastic. You go right ahead and do that. Okay, I'm going to scoot this over. I don't really need the picture anymore so that I can see my calculator a little bit better and have it ready. So cosine of the angle is 55 degrees. It's always an acute angle, never the right angle. And that's equal to the adjacent leg, which was the 33 down here on the bottom. Well, I'm not actually finished with my picture after all. The 33 down here on the bottom is adjacent, and the hypotenuse is the x. And here's where the proportion really comes in handy, because in this example, the x is on the bottom, and that makes it harder to solve. So the trick is the same as we used before. Put the cosine 55 over 1 and cross multiply to solve this proportion. Okay, so cosine 55 degrees times x, and I'm going to put the x in the front because I want my cosine 55 to be on the end. So x times cosine 55 degrees. Notice I treated it exactly like the last two problems. I just have an x instead of a number as a coefficient of the cosine 55. That's equal to, in the other direction, 1 times 33, which is 33. Notice that this one is not solved in one step. This one's going to require a second step to solve. We need the x on the side by itself, and it's not on the side by itself yet, which means we're going to have to divide by cosine 55 to cancel out this cosine 55. That's a multiplication symbol right there. Division is the undo, the inverse operation. So I'm going to divide the left side by cosine 55 degrees and divide the right side by cosine 55 degrees. So this is an extra step we didn't have to do in the last two examples, because in the last two examples x was in the numerator instead of in the denominator. Okay, on the left side of the equation, cosine 55 over cosine 55, those equal 1. Anything divided by itself is 1. That leaves us with just an x. That's what we needed, was just an x. And that's equal to 33 over cosine 55. Well, this side can be simplified in this last step. That needs to go in the calculator. So 33, oh okay, maybe I'll do control divide to get a fraction template. And do 33 over trig, arrow over to cosine, press enter to paste it in, put a 55 in the parentheses, and that's equal to about 57.5. We don't know again what the units are. That makes sense. We have this short leg that's 33. The long leg being 57.5-ish. Makes sense. That's a reasonable answer. Now, let's look at this online calculator to see what that looks like when we don't have the Inspire. So I do notice on this handy dandy calculator, there's a fraction template right there. I've never used it before, so we're going to play with it together now. If I click on that fraction template, it literally gives me a fraction template just like the Inspire did. And I'm going to put on the top 33, and then I can click on the bottom and put in cosine of 55. It looks identical to what we did on our handheld. And press enter, we still get 57.5, same answer. So it works pretty much the same way that your handheld calculator does. Very friendly machine here. Okay, so finished with that. All right, so for now we're going to call this it for the day. We do have a word problem on the next slide that we're going to go back and tackle on Wednesday. So we're going to kind of skip over it for now. For today, your homework is to complete page 16 in your packet, and it's just 10 practice problems. And in your Unit 8 folder, there's a separate Unit 8 folder in your Schoology that has all the Chapter 18 materials in it, what we would normally have access to if we weren't doing NTI days. And in that is a scan of all the answers for the packet. So check your work as you're working, as you go, and then take that homework check quiz when you're finished with the page in the packet. That's how you get your daily grade, is by taking that homework check quiz. Alright, so tomorrow we will learn how to solve for missing angles. So it's just kind of the flip side of what we did today. And then Wednesday we'll throw in a couple of word problems, and we'll be ready to start reviewing for the next big test over Unit 8. Alright, hope everybody's healthy and hanging in there okay. And until I see you again, have a good day.